Hey everyone. So we are into a new chapter, chapter 10, which is chemical quantities. We are now starting to get into the math section of our chemistry knowledge, okay? We are going to be talking about balancing chemical equations today, and then later on we'll start getting into the actual converting of grams to moles, moles to molecules, molecules to atoms, which you'll understand once we get there. But first things first, we got to look at an actual chemical reaction and learn how to balance it. So that's our goal for today. So the first thing we need to talk about is the law of conservation of mass. The law of conservation of mass. And you've probably heard of this before. Let me rewrite this. Law of conservation of mass, which states that mass is not created or destroyed, it only changes form. So mass is not created or destroyed, it only changes form. So in terms of if you have a piece of wood and you were to burn it, the wood may seem like it disappeared, but really it did not. It just turned into things like ash, CO2 and H2O. Okay, it turned into smoke. That is what the law of conservation of mass is. We actually never lose mass. We just change it into a different form that we may no longer see. So at the beginning of the universe, when it was created, the same amount of mass that was there is still here today. Okay, there isn't any more mass being created. There's not any disappearing. Again, it is just changing forms. And that is really important when we're talking about a chemical equation, because the amount of reactants we have at the beginning, we should have the same amount of products at the end. And an example of that is something like this. Say we got silver and it's going to react with hydrosulfuric acid and it will become silver sulfide and hydrogen gas. Okay? We should have the same amount of each element on the left side that we have on the right side. Remember that the left side, we call those the reactants, and the right side, we call that the products. So when I say reactants, I'm talking about the left side. When I say products, I'm talking about the right side. Well, let's look at this. Right now, I have one silver atom. I have two hydrogen and one sulfur atom. Over here, I have two silvers bonded to a sulfur, and then I have one hydrogen atom. I should have the same amount of elements on one side that I do the right side, okay? So I'm looking at this. I have two hydrogens. I have one sulfur. I have one sulfur. And I have two silvers, but over here I only have one silver, okay? So what we do in order to make sure that the law of conservation of mass is met is that we just put a coefficient in front of silver. That now tells me that I have two silvers. Okay, so now you're going to be seeing larger numbers out in front of our compounds. All these have an imaginary 1, they're just not shown, but we'll put a 2 here. Now we have two silvers, one sulfur, two hydrogens, and two hydrogens. And that is a balanced chemical equation. Right? Let's go ahead and let's do a bunch more of these so we make sure that we have it down. So our next one is going to be a combustion reaction of methane with oxygen gas, and it's going to create CO2 and H2O. All combustion reactions that deal with the hydrocarbon create CO2 and H2O. And I'm going to put these dashed lines here because we're going to put coefficients in front of these to balance. Alright? A tip for you, elements that are by themselves, like oxygen, it's just one thing that's by itself. It's not paired with another element like carbon or hydrogen. Let's save those for the end. Okay? So let's start looking at this guy and let's just see what we need to balance. Okay? Carbon. I have one carbon over here. I have one carbon over here. That seems good. I have 4 hydrogens with this methane, but I only have 2 hydrogens over here. So if I have 4 hydrogens over here and 2 hydrogens over here, what would I have to put in front of that water in order to make sure that I have 4 hydrogens on that right side? I'm going to put a 2, right? Because now I have 4 hydrogens. 2 times 2 will give me 4 hydrogens. Now over here, I have 4 hydrogens as well. So let's make sure that nothing else changed. I know carbons are good still. I know hydrogens are now good. Now let's look at our oxygens. Remember to count up the oxygens from all of the compounds. I have 2 oxygens from this guy. And right now I have 2 oxygens from that guy. The 2 in front of the H2O tells me that I have 2 hydrogens, or 2 oxygens, sorry. So that means total 2 and 2, I have 4 oxygens. But on this side, I only have 2 oxygens. So I am once again going to put a 2 right there. So now I have 1 carbon, 4 hydrogens, 4 hydrogens. I have 2 oxygens there, 2 oxygens here for 4, and I got 4 oxygens there as well. This is balanced. You can go ahead and put a 1 in front of these if you want to. You don't have to, okay? They're implied if they aren't put there. And this is another balanced chemical equation. I saved oxygen for last since it's by itself. Let's do another one that's a combustion reaction, okay? Or let's do something a little different here. Let's do iron, and it's going to react with oxygen as well. This is an oxidizing reaction, so this is actually rust, okay? And then we're going to do Fe2O3. So this is the process of oxidation of iron or rusting. So again, we got iron by itself and oxygen by itself. Let's just leave those guys by themselves for right now. We could start with either one, okay? It doesn't matter. Let's just go with what's easier. Oxygen, you see I have 2 over here and 3 over there. That means I gotta make both of those 6 at some point. So, in order to do that, right, if I have 2 oxygens here, 3 oxygens there, I have to make them match their lowest common denominator, which is 6. So, in order to do that, I'll put a 3 here. That means I have 6 oxygens. And I'll put a 2 here. That means I have 6 oxygens, right? 2 times 3 is 6. 3 times 2 is 6. Now, let's look at our iron. Over here I have 1 iron. Over here I have 2 times Fe2 is 4 irons. So in order to balance that, I will just go ahead and put a 4 right there. Let's double check. 4 irons, 6 oxygens, 6 oxygens. Right? Let me throw a trickier one at you. Let's go with, I got sodium nitrate. And it's going to react with lead oxide. And it's going to form lead nitrate. Let me rewrite this because I don't like how I'm out of room. So again, combustion through. And it will form our next one, which is sodium oxide, okay? And now, let's balance this guy. Go ahead and try it on your own if you want, but we're going to go through it right now. So, I'm looking at this. There's a lot of things that are by themselves, and one thing that you'll see is that we have a polyatomic ion of nitrate. Remember how I said that polyatomic ions pretty much act as one singular element, so don't separate it out into nitrogens and oxygens. Just keep it together. So it's like I just have one nitrate here and two nitrates over there. So let's go ahead and let's balance this. If I have two nitrates over here and only one nitrate over here, let's just put a 2 right there. Now I have two nitrates on my reactant side and two nitrates on my product side. Now let's just start with what we changed next. We now have two sodiums, because I put a 2 in front there. Let's check over here. Hey, I have two sodiums. Cool. So that's good. Sodiums are good, nitrates are good. I got one lead. I got one lead. I got one oxygen that's by itself. I got one oxygen that's by itself. This thing is balanced. Right. Let's go to a tricky one where you'll see something where you actually get a decimal as a coefficient, okay, which we can't have. But let's go ahead and let's look at that. This is ethane, and it's going to combust again with oxygen, and it will form CO2 and H2O. Once again, we're going to save O2 for the end, just because it's by itself. It won't affect anything else if I put a coefficient in it, just oxygen. So let's go ahead and let's focus on carbon. I got two carbons over here. I only got one carbon over there, so let's go ahead and put a 2. Again, we're going to save oxygen for last, so let's go ahead and look at hydrogen. I got 6 hydrogens over here. I only have 2 hydrogens on my right side. So what am I going to have to put in front here to get 6 hydrogens? A 3. Now I have 6 hydrogens. 6 hydrogens. Now let's look at our oxygens. Right now I only have 2 oxygens, but over here I have 2 times 2, which is 4 oxygens, and then 3 times O, which is 3. So I got 4 oxygens from this one, 3 oxygens from that one. That gives me 7 oxygens. 7 oxygens. Well, I need 7 on this side. So what would I have to put there in order to get 7 oxygens? You might be thinking 3.5, right? 3.5 times 2 is 7. So technically, we have 7 oxygens on this side and 7 oxygens on this side. But here's the thing, we just can't have a decimal there. All right, no decimals are allowed. So what do? We just double it by timesing it by 2. So we'll take 3.5 times 2, and that'll give us a coefficient of 7. Well, if we double that coefficient, we're going to double every coefficient. So we doubled this one. We're going to double that one, which was a 1. We'll double this one, which is a 4. And we'll double this one now, which will make it 6. Let's go and double check and make sure everything looks good. 4 carbons. 4 carbons. 12 hydrogens. 12 hydrogens. Now we have 4 times 2, which is 8 oxygens. 6 times O is 6 oxygens, so 8 plus 6 is 14. 7 times 2 is 14. So that is balanced. Okay, so whenever you see a decimal like 3.5, multiply it by 2, but then go ahead and multiply every coefficient by 2 as well. You won't see anything like 3.33, but if you did, just times it by 3, and then you'll have to times everything by 3. All right, I have never seen something like 3.33 in my chemistry career where I've had to times everything by 3, but every now and then I do see something that is like a 3.5 or 2.5 where I do have to times everything by 2. Okay, let's do one more and I'll send you on your way. So our last equation, let's go with a little silver iodide. We got a little iron 3 carbonate. We're going to go ahead and we're going to do iron 3 iodide. And then last but not least, we're going to do silver carbonate. Again, I look at this and I see a polyatomic ion. Just keep it together. Don't break it up into carbon and oxygen. Okay, just leave it as is. So let's just start with carbonate, just since I brought it up. I got 3 carbonates, right? It's in parentheses and there's a 3 out on the outside, so that tells me I have 3 carbonates. I only have 1 carbonate over here. So let's put a 3 in front. So that changed my carbonates, but it also changed my silver. So let's just stay over here and see if we can balance the silver. 3 times Ag2, right? I had 2 silvers originally, but now since I put a 3 in front, that means I have 6 silvers. So I'll go ahead and put a 6 on this side. I now have 6 silvers, but I also now have 6 iodines. Over here I have 3 iodines. So I'm going to put a 2 there. Now I have 6 iodines. But when I put that 2 there, I now messed up my iron, which is okay because I have 2 irons over here and 2 irons over there. Let's double check everything. 6 silvers, 6 silvers, 6 iodines, 6 iodines, 2 irons, 2 irons, 1 carbonate, or sorry, 3 carbonates, 3 carbonates. That's it, guys. That is balancing chemical equations. There's some practice for you to check your answers. If you struggle with this, it's okay. I know some grown professors that have trouble balancing. Give you some practice, you'll get it, you'll do great, okay? If you have any questions, let me know. Have yourselves a great day.